Okay, cool. So we're going to continue on with section 7. We're actually going to talk a little bit about section 6. So just know that it's object-oriented programming. We should have been introduced to it since last time, but now we're going into some other techniques that we can do, as well as some stuff from section 6. For example, like properties. We didn't talk about that last time. So one thing I did want to show you guys is on the student resource page. Okay, so you guys should all have access to this. There is obviously all the videos, including videos and recordings and resources that other instructors have put together. Definitely check this out, especially as we get further into the sections. But one I wanted to point out was this Google Drive section here, which one of the instructors, Eli, put together. You might have seen this before. This is from him instructing for his object-oriented programming. You can see he has a slide deck here that goes through some info. Oops. Whatever. It goes through some information about object-oriented programming. Of course, know that it's a slideshow, so it's not going to have all the information, but it might be a good thing to kind of check out to see his different style, how he taught it or instructed it. And then there's a good list of resources here. So there's some video links. I actually don't know what these video links specifically go towards. They might actually be for other, not even part of Flatiron, might be something else. So just be aware of that exists. And then basically things that you should kind of focus on, saying like what you should be able to do. And this, again, this is for section 6 and section 7. And of course, he does a really great job. Eli does a great job of putting out resources. Again, the numbers don't mean anything. It's just more like there's just a list of different resources. And there's plenty of resources on object-oriented programming. Okay. All right. And of course, there's also some notebooks here that he goes through that you can download and run it yourself. They usually are pretty close to the curriculum's notebooks to just summarize, kind of similar like what I'm going to do today. All right. So definitely check this out. Yeah, you guys can find it on the student resources, but I'll go ahead and share it out in the Zoom right now. Has anyone seen this resource yet? Come across it? No? Okay. So I'll send that right there. Okay, and that's specific one. But anyway, I wanted to show you guys that. So let's go right into what we talked about last time. So last time, let's turn off my phone so it doesn't keep bugging me. Okay, last time we did intro to programming. I kind of explained how, if you guys remember, object-oriented programming, we build classes. Classes are kind of like a blueprint. I think of it more like a mold, you know, kind of like something you pour the plastic into and you make this mold, and the thing that comes out in that from the mold is the actual object. So that's instantiating that object. So I'll keep using that metaphor, okay? I did want to just mention a little bit before we go into the next part we talked about methods and variables and then using the self. So I kind of went through this last time very quickly, so I just wanted to mention again, is that, what's it called? Our methods are just functions. Okay, we call them methods in object-oriented programming because they're tied to that object. So just know that like when we say a method, it really means object. It's the same thing. Turn off this guy, sorry. And that's here. The way we define these methods so we can tie them to our object, we use this keyword called self. So you remember we defined our class right here, and our class, like we said before, looks just looks very similar to like a function declaration. You can see we have class, saying it's a class. The robot, basically, in this case, is my special little robot friend, a little object. And I have basically these variables. In this case, these are just tied directly from the mold itself, giving it default, name, material, is electric, number of arms. And I also, in this case, defined a couple of functions. For example, I did a function called speak, and I use self to basically tie it directly to the object. So what happens when I create my new robot, down here will be Wally. Okay, when I create that new robot, it's going to have that function tied to it, right? It's going to be able to use this function directly. And we use that function by doing using our dot method. So if, for example, I do self, basically I just do dot speak, and it'll basically say whatever its name is, if it's none, or if I assigned it, whatever. In this case, this is a little more complicated function, but still same idea, is that in this case, I create a function called add numbers, and I tie it directly into the object. And then these are the two parameters, number 0, number 1. And the idea here is they pass two numbers together and it'll return total, okay? So hopefully this feels pretty familiar, just to kind of show you guys, right? I create my robot here, and you can see that these are all the default values: name, material, is electric, number of arms. We have, I think I showed you guys a function .speak. So that's how I call that function that's just tied directly to that object. dot speak, and you can see I am none. He doesn't have a name right now. We have given him a name. And then I can also call this function here called add numbers, and this will call this directly. And you notice that I don't put the self here, it just ties it directly. That dot notation is essentially saying, oh, use this object. That's what that self does. And I say, okay, add these two numbers together, so that will return 101. Note, however, too, I never specified it had to be integers or numbers. Can we add strings together in Python? A little fuzzy on this. Can we add strings together? Let me ask you guys. Can, what was that, Rudy?
Yeah, we can add the strings.
Oh, Giovanni. Yeah, we can add strings. So A plus B, yeah, that works, right? So if I do this, right, this will actually return, 100 plus 1. So just know that we can kind of have this little extra functionality. But anyway, that was kind of a little side note. But the main idea here is this is our self. We're tying it to that object. And that method now, that add numbers method, belongs to this object, okay? And note, if I change the parameter or one of the attributes here, in this case, Wally's name to Rob, okay? When he speaks, he'll say, I am Rob, okay? And then I said this extra thing, you could redefine the function. This is tricky, you never really see this. I just wanted to show you guys that in the end, it just ends up being a function, okay? Any questions? This was review, but I went through it really quickly last time, so I just wanted to at least show you guys one more time. Cool, thumbs up, sound pretty good? All right, so ready for some more stuff. So we're gonna go into getters, setters, and deleters, which I think everybody just loves, when we talk about the curriculum. I saw all in Slack that you guys know it perfectly and have no issues at all. No, I'm sure. Getters and setters, I think, can be kind of tricky. It's a different philosophy. Just know that getters and setters, just like object-oriented programming in general, there's not like a reason why you necessarily have to do it. It's not like you can't do things without doing this stuff, but it's a philosophy and kind of a methodology, so it's consistent throughout the way, okay? So you'll see that we call making things private. The idea here with like setters and getters and deleters is to basically remove, have one layer of abstract, like one abstract layer, or one layer removed, right? So instead of calling it directly like I did with the dot name here, okay? In this case, in order to know what the name is, I have to do a dot name and I have to know what this part is. And then to assign it, I have to do dot name equals and stuff like that. Ideally, we would want to have everything abstract. So the person coding, and it's kind of like, I'll say like the user, but really it could just be you, right? When you call this information, you don't have to worry about saying, wait, does it have to be a string? Does it have to be an integer? Do I have to worry about certain values? That's the whole point of getters and setters and deleters, is that you can basically remove that extra information from the person using the object or class and basically just proceed forward, and they don't have to worry about that extra stuff. So one thing we do is in other programming languages, know that when we do object-oriented programming, you can actually make variables private, which means literally no one can access that variable. In Java, if you're ever familiar with Java, you can actually set things like private and static and stuff like that. Python, by default, everything is public. Basically, if the variable exists within the class, you can access it. But just know that we call things that are private variables. By convention, we do an underscore in the front. So an underscore and then the example name. So we'll show an example of this in a second. But the main idea here is that we call a private variable, even though it's not really private, and we denote it with an underscore to make that distinction. Say, oh, this is something that a user, I say a user, a programmer doesn't have to worry about. They shouldn't have to worry about this variable. So just know that that's what the underscore means. Okay, cool. So we're going to use this for methods. So in this case, I'm just going to start with the set and get, and then we'll look at delete attributes. Or I should say methods instead. So I have my method here, and we've been using the robot class over and over again. I've been making this, right? So I have my robot class, okay? And then you'll see here, I have that underscore name, so okay. So now we have a default name too. In this case, we just put none, but basically the idea, so we have some default here. And note that we have an underscore name here, okay? And we do an underscore name here basically to make it easier to, what's it called? To reference, be able to reference the variable, okay? So we know that's a private variable. So in this case, we set the name, a setter, right? And basically note the set name. What do we need to set something? Well, we need to have the object itself, okay? And then we have to say, hey, what are we setting the name to? In this case, it's called new name. So we have self dot underscore name equals whatever the new name we pass in. So this will set dot underscore name. Note when the user, when we call this set name, we never have to know that an underscore name even exists, right? We just know it does. Like when we set the name, it will set some property that, you know, will be called name. And so similarly, if we get name, in this case, if we just want to call the function get name, we don't need to pass anything into the function. We just say, hey, Wally, you know, Wally object, go ahead, or say robot object, but robot object, go ahead and give me your name, and basically say, all right, and it gives you your name, okay? And then similar to this is defining a deleter, okay? These tend to be a little less common, but it's good practice. It's kind of like getters, setters, and deleters, but we can delete the name too, and basically say delete name, okay? In this case, I put del name, just to make it nice and easy to read. And basically it'll delete that, whatever that name is. Note that, again, the user never has to worry about exactly what does it do to delete the name, okay? So we'll see how this works in practice. So I had to define my class here. I'll define my Wally robot. So in this case, remember, this is not the actual name, it's just the name of the variable. So right now, Wally robot. So if I ran like, you know, get name, for example, it won't have a name. It'll say none. So just to kind of show you guys, to make sure you guys understand. So get name, remember, doesn't have anything. You can see it doesn't show, it doesn't run anything because it has nothing. If I did print, it'll just show none. So that's because we set the default to none, okay? But anyway, I just wanted to show you guys that right now he has no name. So we can set his name, wally.setName, okay? And we just give it some, what's it called? Some string. In this case, we can name it wall-e, Wally, right? So we set his name. And then similarly to get name right here, we can now get his name and we can see that we get Wally, okay? And again, the user, me, the user, if this was all hidden away, which is what we do in the curriculum where we basically make it into a new file, if I never saw this class, but I knew there was a dot get name, dot set name, and you know later on we'll see a dot delete name, I never have to worry about how it's defined, okay? So that's kind of like the big advantage of like why we have deleters and setters and getters. And you can see I delete the name now, and so when I print his name, he has no name anymore because we deleted it. Okay. Any questions about how this worked out? Okay.
So I do have a question, Victor. So you're saying you don't need to worry about how it's defined because by convention, everyone would use getters, setters, and deleters the same way.
Yeah, that's the idea. When I say like you don't have to worry about it, it's the idea is if it's well written code with object-oriented programming in mind, because we can treat it becomes a little more natural and more fluid versus like saying like, what are all the little properties? I think last class, I think it was Ali asked, is there a method we could use to see what all the properties are? And you can imagine like this one's only got like, you know, its name for a robot. But if you had like a really complicated object, which there do exist, where you might have literally hundreds or even thousands of different properties and names and stuff like that, it might be really cumbersome to figure out, you know, which one do I set to? And remember, Python doesn't have any like type verification. So for example, if I want name, if name can only be a string, and I had to manually do, you know, Wally dot underscore name equals, and then put in a string, well, if I put in a number, that might break the code within it. Maybe I didn't ever check for a number. So this kind of helps it remove one layer. So I, the coder who create the class robot, doesn't have to worry about another user essentially accidentally breaking their instance of the object. And it makes it easier for the, you know, user, the other coder, the other programmer, to basically use that object without having to worry about all the nuances underneath. So for example, I'll show an example in a second, but this name, for example, maybe when you set a name, you automatically make it uppercase. So that way you as the person who's putting in, you know, oh, name Wally, you know, give Wally a name. You don't have to worry about making uppercase. You could have the code automatically do that for you. Okay. Hopefully this will get a little more clear as we go through. Does that answer your question, Tara?
Yeah, I guess kind of. Yeah,
okay.
Let's keep going.
Okay, yeah, and if it's still not clear, you know, definitely bring it up again. Okay.
Thanks.
So again,
can I also ask a quick question?
Yeah, go ahead.
How are those classes different from, say, libraries?
That's a good question. In a lot of ways, they're not. A lot of times, they're exactly the same. We'll see in inheritance, for example, that you can actually have library, like basically classes within classes, basically inheriting. And that's kind of like what a library does. So for example, if you can think of, it's not quite right, but you can kind of think of this as that NumPy being like this big class. Pandas, you know, what we've been using a lot, actually inherits a lot of the stuff from NumPy and borrows the same methods and structure from NumPy. So that way, the person who first created Pandas, there's still a lot there, but they didn't have to create everything from scratch. They could go ahead and use the NumPy package. So a lot of the library is in a lot of ways like the same. Like it just depends on how it's structured. But a library, like when we say like import, like I think I had it in the very, I don't have it here. But if you do like import pandas, right? Pandas could be a bunch of different classes underneath there. It could also be specific code that can run too. So it's related, but they're not exactly the same.
Okay.
Good question though. And I think that's probably comes from the fact that in the curriculum, you do an import like school, right? And you have a school.py. And that's in a lot of ways, when you import it, you basically are importing also that class. But you can also import just functions. Maybe I'll show that another time, but I won't go into it today, unfortunately, unless we have time. Okay. So, so going back to our setters, getters, and deleters, we have our set, get, and delete. And we can use a property. And so the idea here with property is that we can basically, since everything, the idea is that every object-oriented programming class, right? Basically with OOP in mind, we can always say, oh, there's gonna be a setter, there's gonna be a getter. In reality, there might not be a deleter, but usually there should be a deleter if it's best practice, right? So you can actually use the property function to basically help you define this so you don't have to, you can make it really clear when you're writing the programming. And so this is straight from the documentation. You can look this up. If you just look up Python property, you can actually find this direct link and basically read the whole thing through. It's a little confusing, but the idea here is that we use the property so we can actually say, okay, go ahead and make this the setter, make this the getter, make this the, what's it called? The deleter, okay? Instead of having, you know, you can see set name, get name, delete name, it just kind of gets cumbersome. So this is usually very common. And so I believe the curriculum shows this method the most, right? Where you have a class, and in this case, they kind of wrote it more in one line, but don't worry about that too much. But basically they have a get X, a set X, and a delete X. And you can see these are just functions, right? And you can see there's that private variable dot underscore X, okay? And then basically it just says, all right, whenever a user calls the variable X, it'll use this property, basically, oh, this is the getter, this is the setter, this is the deleter, okay? And then in this case is documentation. So we'll show a little more about this, but just know that's what the documentation the curriculum mostly goes on. What I'll show too is also using this decorator part, which is probably more common, at least in my experience. I've seen people use the decorators the most in their code, okay? So again, I kind of went through this. We didn't go through the full details. I'll explain more if you haven't seen properties before. If you've already tried out the assignment, you probably already know a little bit about properties, okay? So we'll go ahead and try to do this now. So again, we're gonna do the same thing. We're gonna complicate our object a little bit more. So we have an underscore name, underscore last name, underscore first name. So I'm just writing some defaults here so that way, in case it doesn't ever get initiated, we can actually, you know, use this by default, and we'll see some extra methods. So we have the same thing. We have a get name, a set name, and this word is actually my set name. You'll notice it's a little more complicated. So I still pass in a single string. In this case, I hope it's a string. In this case, I'm actually going to make it capital. So I'm going to capitalize it properly. I'm going to do a split. So make sure I get first name and last name. So I actually get this name that someone passes in for me. And the idea is here, like I can actually do some extra stuff. Doesn't really matter exactly what's going on here. It's not required in that sense of like understanding what objects, how to do OOP, but this is something you could do. For example, when I set the name, I also by default automatically set the first and last name by using some extra stuff in the back end, okay? And again, the user never has to know that this happens, right? I mean, shouldn't know, you should document it, but like they never have to see it actually happen. All they have to say is, hey, if I set the name with a string, the documentation says when you set a name, it will set the name and then also create a first name and last name. So that way you kind of know, it's like, okay, that's all I have to do. So I have a set name here, delete name here, and then I have, this is what the curriculum shows, is name equals property. And then I just made it explicit that I have the getter first, the setter, and the deleter, okay? And so now what happens when I have this guy is now when I create my robot, all I have to do is called dot name, okay? And so I don't have to worry about, like, this is in the back end, it's not setting the dot name. There is no dot name property here, right? I never defined a dot name. What it's actually doing is actually using the setter right here. So it says, oh, Wally dot name, hey, you're doing an assignment. Do I have a setter? And the object looks like, oh yeah, I have a setter. It's called get name. So this actually calls get name right here. So this would be the same thing if I did Wally dot set name to Wally. These two are literally the same thing in this case. But I didn't have to know what dot set. I didn't have to know as a user that there's a set name. I can just say, hey, Wally dot name equals this, and it will actually call the setter, which we saw was a whole bunch of complicated stuff. Okay. And then the same thing with our Wally dot name here. When I do the getter, it's actually calling get name right here. It understands like, oh, you're trying to access the property dot name. Well, okay, that's just using the getter. So I use the getter right here. And then same thing with the deleter here. So you can see this should function fine. So I get the name Wally, delete the name, none. Just to kind of prove my point, I'll just, let's hear set name. So I can actually call this explicitly, right? So like I said, show I'm not a liar. Okay, so right now, Wally shouldn't have a name. And if I do a dot set name now, it'll actually call this over, and you can see he actually shows up here, right? And I'm gonna go get rid of this deleter just to make it a little easier. I can also, now normally you wouldn't do this, but just to show you that it is calling that dot set name. Because remember that dot set name, it's not just creating a name, it's also, in this case, creating a first name and last name. So just to show you that exists here, is if I do dot first name here. And again, you normally wouldn't do this as a user. I'm just kind of showing you guys that, hey, this is actually happening. Okay, you can see it has that first name here. It understands, it set that in there. Even though as the user, I never called, I should make this more clear too. If I do dot name equals, right? If I do this right here, and sorry guys, I just realized I have to delete this name. There we go. Just to make sure I have his name gone. So I can do this dot name here, and it'll call the setter by itself, and it'll actually create this first name, even though I never used it. So you can see here, I actually created a first name here. Does that make sense? Any questions on this? Okay.
Yeah, I was just wondering why it says f get equals get name in the property. Oh,
like why is it?
Yeah, f get, f set, f delete. I don't remember that from the curriculum.
Right. Yeah. The reason why is because, but if you put in the right order, if you put just the getter first, the setter second, and then deleter third, it'll know, oh, that's the order I'm supposed to put it in. But okay, if I put in, for example, like if I switch f set, if I put the setter like first and the getter second, I'm just making it explicit. So this is where you can, just in Python, this isn't a special property thing. In any Python function, I could have set the name. For example, when I call like dot set name, like if I were to do Wally dot set name, oops, I could do something like new name equals Wally. Basically that's saying, and I'll put it Wally so it's different. You can see here, it calls it like this way. So that's all this is doing right here, is that it's saying, oh, or in this function right here, it's saying get the getter is get name. I could have taken that out. I just made this kind of so it's really explicit to say this is the getter, this is the setter, this is the deleter. Make sense?
Yep. Thank you.
Cool. No problem. All right. Good questions, guys. All right. So anyway, that's property. And now I'm going to show you the same exact code, but using the decorator property. So I put some documentation here too, to actually show thing. Note that decorators can, the documentation can be a little confusing. I found a good blog post here about decorators in Python. There's not just property, there's a bunch of other decorators, and you'll see this actually, for example, if you use for machine learning code in TensorFlow, they love to use decorators to basically say, hey, this right here is a certain kind of machine learning aspect, and you can basically use decorators to do that. So it's a good thing to know overall, but we'll, I would say like it's more advanced. Like I probably spent my first like 2, maybe even 3 years never knowing what a decorator is and just knowing that there are these weird things that sometimes appear in code. So I'm kind of giving you guys a heads up, like, hey, if you are curious, and it'd probably be good, look over this. And I would say, look at, this is probably more easily understandable. Okay, but just know it's doing the same exact thing in this case. So I have the same code. In this case, this is just my getter. I'm sorry, yeah, my getter here, okay, my setter here, and my deleter. And note that I just basically have this name here. If you do the document decorator like this, these would be the same. And this basically, instead of having our name equals, like we had up here, name equals property, the way it knows it's the property name, you can just put the name of the function here. Okay, and basically it just has this property right here, at property for the getter, at the setter. So I'm just showing you another method that will likely, you'll probably come across at some point, just because this tends to be more common. Okay, and just note that it works exactly the same. I would say look it over. You know, if you clone or fork this repo specifically for this workspace, you can play around with it and copy that code and see what works, see what doesn't work. Okay, and again, highly recommend reading that article. But again, just to show you, it's just the same thing. Okay.
Can you put that link in the chat? I don't know if I know who that is.
I can put this guy here, and then I'll also put in, I think, oh, and then that very first link I have, I'll just send it one more time. That is the GitHub repo for the object-oriented stuff. And note that whenever I do lecture study groups, whenever I do study groups, if I have a thing like this, like some workbook, I'll usually put it into the GitHub repo on that link, so that way you guys can access it. But yeah, I shared both of those guys out. All right, so any questions on property, getters and setters at this point? And feel free to ask questions at this, like, properties not, getters and setters are not usually the easiest thing to understand, at least in my opinion. Cool, so moving on then, sound good? Thumbs up if you're good. Sideways if you just want to look at a little more. Okay, yes, so some quick sideways, okay, cool. Yeah, so hopefully, you know, just kind of get used to it. I think the biggest thing is practicing. The more you see it, the more kind of like familiar you become. Just know basically your getter, all you do is it's a function that says, hey, give me the thing. A setter, you're basically setting the thing, okay? And then deleter is like you delete the thing. And what the property does, you know, this probably makes more sense just looking at it right here for the first time. Just know that the decorator part is more common. Basically you're saying, hey, property. So whenever we use name, basically the object, the class is smart enough to, Python's smart enough to say, hey, when you do a dot name, are you trying to do a set? Are you trying to set it? Are you trying to get it? And basically it says, all right, if I do like Wally.name and I'm making it equal to something, it's like Python's like, you're trying to do a setter. So I'm going to go ahead and use the setter property or setter function that you had in property. And then if it's trying to do like a print, it's like, oh, you're probably trying to do getter. So I'll call the getter function, you know, that you assigned in property. Okay, and that's kind of what's going on. So this makes it a little bit easier where, I mean, it kind of like puts a little bit more work on the person writing the code, obviously, right? Like you have to now think about, you know, making this property, but hopefully it's not, doesn't seem like too much more work, and it makes the code a lot easier to work on when you're actually using it, which is the whole point of making a class. The whole point of the class is not to make this stuff, it's to run this stuff, okay? And if it's done well, you never notice that this stuff even exists, this kind of like crazy mess. For example, almost every time you do an import, basically they're doing something like this in the background that you're not even familiar with. Okay.
Victor.
Mm-hmm. Yeah.
So if you don't use like the properties set name, get name, and you're just using the dot name, mm-hmm. and let's say you already set a name, but you wanna change the name. Mm-hmm. You wanna set a new name. How the function knows you're trying to do that?
Yeah, so this is interesting. So you're saying like I have this part, I have the property defined like this class right here, mm-hmm. right? And then you're saying, okay, when I do this thing, like for the very first time, how does mm-hmm. it know, like to use in this case, to use the setter? Is that what you're asking?
So if I equal if I do like where you're pointing at, where Wally.name, and then if I write a name there, it's gonna know that I wanna set a new name.
Mm-hmm.
And if I don't write anything, it's gonna know that I'm just trying to get the name.
Right. So like if I write this versus like if I do like a print Wally.name, right? Or even just like this by itself, right?
Mm-hmm, mm-hmm.
Yeah. And then if I run this, it'll automatically call the getter, which is very different from the setter. Okay. Are you asking like, how does it know?
Yeah, no, now I figure out. Sorry,
Okay.
I got confused for a second.
Yeah, it's a little mind-bending in my opinion. The short answer is that Python's being really smart in the back end. It's doing some stuff. And it's like, hey, like basically every time, like this is kind of a weird thing to realize, but every time even just like having the word like Wally like this, and you see that it prints out its memory space like we talked about last time. Wally basically, when we just do this, Python in the backend actually is calling a getter to basically say, hey, what does this exist? So actually you've been using OOP since the beginning, you just didn't realize it. And that's why OOP is so powerful, because it's like, oh, you don't even have to realize how it's working. You just have to know that it works. And that's kind of the idea with getters and setters.
Mm-hmm. Got it, thank you.
Cool. No problem. All right, any other questions? Again, I'm willing to take a little extra time on this because this is a little more confusing. So, but these are all great questions. So anything else? Otherwise I can move on to instantiation for defaults. Cool. All right. So I'll go to the second part. So using defaults for instantiating. So this is where we start getting into more like, you can kind of, there's just a whole bunch of things going on here. Basically, I'm doing a bunch of properties, in this case, last name, then first name, okay. Oh, sorry, first name, and then I have name here. So know that I'm just basically creating other properties, getters and setters for multiple variables, okay? But the main thing I wanna show you guys is something new, this guy right here, this underscore underscore init underscore underscore. So one thing you should always note is when you write this right here, first of all, you see an underscore, it's a private variable. That's not for normal people. That's just for us to program stuff, right? So you will never like call underscore underscore by itself. You could, but it's not usually common practice. So just know that's what the underscore means. And this double underscores, you'll see underscore underscore, and then init, and then underscore underscore. Always be careful. I think Joe said, make sure you have that double underscore, otherwise it won't recognize it. But when you see these double underscores, know that's a special variable for Python. Basically, Python's like already keeps this in like, it's kind of like bag of tricks and says, oh, double underscores, those belong to me. Like basically, those are my special variables. And so this is already built into here. So just know if you ever see another thing like another double underscores, it's something that's built into Python, okay? But this one allows us to basically create an object with some extra defaults. So before, if you remember, when I called like Wally over here at the very beginning, this robot part, I still had to set the name by itself. And I could do like this default here, but it would be nice to be able to like put something like, oh, like, I want to name him, the letter A. And it's like, oh, can't do that. It's like, it would be great if I could just like automatically, it's like, hey, I'm going to use this Wally character. I would just like to be able to give him a name right at the beginning. And that's what this init starts. And I'll call it init initialize, right? But this underscore underscore init basically is saying, hey, when you call Wally equals robot, you can actually use these parameters. And so basically it's like, okay, here's the tied to the object itself. The first parameters will be its first name. Its second will be its last name. And note, I gave it default parameters. So that means if I leave it blank, it'll by default will leave, for example, it'll make the first name generic and the last name just blank. So just know that's what these parts right here. I could have taken this part out. This is not necessary. It's just good practice to have default values if you know what they could be. So just kind of know, this kind of related to, I think, what Thomas brought up is like, like, oh, what are you doing with that equals part when you're calling a property? This is kind of similar, except in this case, we're just defining it. Okay. So in this case, I basically, all you have to know over here, and you can check out the code a little bit later. I'm not going to go through it because it's just Python stuff. I want to focus on the object-oriented part, is that when I initiate my robot, I can say first name, this is your first property, and then last name, second property. So I'm going to run this, and I'll show you my robot right here. And you can see my generic equals 0 equals robot, okay? And notice that it's kind of similar like we had before with like Wally equals robot, but this case, it actually is calling, and I'll make these small so I can see this a little better. Can I make it small enough? Okay, there we go. So you can see here is that by default, it'll make the first name generic and the last name blank. And I never have to call it myself, okay? So when I do this guy right here, if I run it, you'll see he has a generic name, okay? His name is generic, okay? And they have a last name, doesn't have a last name because it was blank, right? Or I shouldn't say, it's an empty string. And then generic, his first name is just the word generic, okay? The next thing I could do, just to kind of show you that how this works, I could also have done last name equals, I don't know, Z, okay? And basically it'll say, okay, it'll first look for say, hey, is there anything that's a name parameters? Oh, you named, last name Z. So that means like, okay, that property, last name Z. It's like, did you give a first name? And it's like, no, you didn't give a first name. All right, so we're just gonna use the default parameter generic. So you can see here, this should actually give generic Z, and then it'll give a, in that square brackets will be Z comma generic. And you can see that's what pops up here. Make sense? Okay, cool. And that's how you can use default parameters. And now you can see I can also give, without having to name it, it'll say Wally, and it'll basically that very first parameter, since I defined it first name first, it will say, okay, that thing you gave me, Wally, that'll be its first name. And then it goes, hey, did you give me a last name? And it goes, you didn't give me a last name. All right, we'll just default to the whatever the default was. In this case, it's an empty string. So now when I do Wally, you'll see Wally, colon, and then, square bracket, comma, Wally. Okay. Does that make sense so far? Thumbs up if that's making sense. Okay, cool. Thumbs down if you're like, oh, I don't know what's going on. Okay, good. Okay. Again, don't be shy if it is. So my last one is I made a Bender Rodriguez here, okay? So in this case, Bender is gonna be his first name here, and then Rodriguez is gonna be his last name, okay? Just because the order of how I put first name first, last name first, or last name second, okay? And then I can go ahead and run this, and so he'll be Bender Rodriguez, Rodriguez Bender, okay? Does that make sense? All right, one last thing I should note is that I could also have done like to make it explicit, I could have been last name equals Rodriguez, and that would give me the same thing, okay? One thing I could not do, and I'll show you what I mean. I couldn't do something like first name, right? Because this will work by itself, that's fine. But if I do first name and find it like this, and then I get rid of this guy, you'll see that it's like, oh, I don't know what to do. And the reason why is Python says, if you're going to give me any parameters that aren't named, you have to pass those in first so I know what order to do, and then you can start naming the parameters. So I could have, for example, put Rodriguez, I could have done, like I showed before, is Bender, because it knows that's the first name. And then I say, okay, the name parameter, last name, okay? And if I had like a third parameter, I could have put something else. But just know that the unnamed parameters have to be done first in order. And then if there's anything else that like left over, I can give it specific names like this. And if you name it wherever you want, for example, if I put first name, oops. And this is more Python, this is not OOP, but I just wanted to show you guys this part since I think you guys will likely come across this more often now, is that if I do first name like this and last name, this will work. Basically, it knows what first name is, knows last name, but it's out of order now. But it'll still go Bender Rodriguez because it knows, oh, that's the first name, that's the last name. Okay, cool, sound good? Okay.
Yeah,
good thing to
Victor,
play
can
around.
you just ask about why it's not capitalizing Rodriguez? Even so, it looks like in the code we are using like the dot title.
Oh, it's because in the last code I did, and this code I didn't. You can see in my initialize function. We can check out like if I do, let's see here.
Yeah, in the setter.
It does it for the first name. I bet, if anything. Oh, okay, last name. Let's see here.
Yeah, that's why I was confused about it.
Yeah, we do last name. Let's double check. That's a good point. So we have our setter, our last name. Oh, I do know why. I did this before. I think I did this with another class to kind of show difference. The thing is in the init function, this right here, when I do our first, I set the first name like this. When I do this guy right here, Okay, this does not call the setter within the init function. And if I try calling the init function, I'm sorry, not the init function. If I tried calling the setter within the init function, it will actually give me an error. And that's because by default, Python goes from top bottom. So basically, by default, I did set it here. If I instead did something like, let's say do, what's it, Bender? So I do Bender dot last name, which now should call the setter, and I do Rodriguez. Oh, well, we'll call it Robo, okay. And then now if I go ahead and run Bender dot last name, which is just called the getter, you can see it's, oops, well, that was dumb, lowercase. And then you could see it's capital. And that's because this is calling the getter. But in the init function, I wasn't careful. And because I wasn't calling the setter, I was setting it directly. I didn't account for that capital. So that adds a little more complexity that you'd have to worry about. And this is what I'm talking about. It's like where these things can be, you have to be careful with how you structure your OOP. Otherwise you might get these weird bugs like this. Okay. Did that answer your question, Tara?
Yeah, I think so. I mean, I'm still trying to wrap my head around it, but it sounds like it has to do with the order in which you ran the code.
Yeah, and you can see when I actually set, you can see when I actually set the first name, I use that underscore first name. I'm not using dot first name. And that kind of gives you a hint, like, yeah, that's not using the setter.
Okay. Thanks.
Cool. Good question though, good catch. All right, cool. So sounds good, I'll continue onwards. So next thing is we can basically do just more basically customization with our functions. So you can see I already have my Wally and my Bender, okay? And you can see I have, when I do a print, so like, okay, when I do a print, it just gives out its memory space. If you guys remember when we tried printing out our objects, right? Our objects didn't actually end up doing, didn't give us any information. It just gives us this like memory space. Like I think I compared it to like saying it's like it's physical space. It exists somewhere. And that's what this stuff is giving me, saying, hey, it's at this memory space, okay? And it would be really nice to be able to like, hey, when I actually call it over, it would be nice to actually have it something readable, right? And it turns out we can, right? So we can actually customize this function here, our class. So you notice this in it, basically it should be all the same stuff, but I just added one extra thing. I added this underscore underscore string. And basically this is another built-in Python method, basically string, and it'll say, hey, whenever the object, the self, right? So whenever I do Wally, and it says, hey, you're supposed to convert into a string, it'll I can actually give it how it should be defined. So right now, when it tries to convert, you know, Wally and Bender into a string, and I'll show you, like, for example, if I do string, right, this should convert, like if I convert this into a string, this will give me like the number 1, right, with a string. If I do something like with this Wally, it'll just give me this thing, right? So what I can do is actually define a way to make that whenever Python tries to make something into a string, it'll actually call this guy right here, okay? So this is how you can kind of add some extra functionality. So I'll go ahead and run this, and just know all that other stuff is exactly the same as before. And now when I create my Wally, my robot, just like before, when I print out Bender and Wally, so just to kind of show you guys a little bit, I run this guy. When I try to print out Bender and Wally now, it'll actually give me the string representation. In this case, I did robot and its name. So Wally, Bender Rodriguez, okay? And you can see here when I actually try doing that same like introduce string, whenever it calls that string str, it'll actually use the function underscore underscore string. Does that make sense? So this is kind of a fun thing to do. This guy right here, I'll send this through this chat right now, but this is actually other things from the documentation. There's a whole bunch of things. So for example, you can define how robots can add together. So you can do that underscore underscore add and actually define when you do, you know, Bender plus Wally, what does that do? Like what should the program do? Right now, if I try to do Wally plus Bender, you'll see it goes up. I can't do that, right? And so you can actually define this functionality and make more abstract functions. And this is actually, for example, like when you do NumPy, when you have a NumPy array, if have we talked about, actually, I don't think we really went into NumPy arrays. That's for, I think that's for next study group, so section 8. So in NumPy arrays, you actually see that we create a new thing around it, and we can actually define adding lists together. So I think, yeah. anyway, just know that this kind of exists, and there's a bunch of functionality you can put into objects. There's a whole list of things. Okay, cool. Any questions about what I just showed here? Okay, again, this is like a minor thing. I actually can't even remember in particular if the curriculum shows this, but I thought I'd show you guys this at least, because I thought this is a pretty nifty thing you can do. Okay, cool. So last thing I have is inheritance. So this is where it gets a little more abstract. This can give a little more parts. I think this will take us to the end of our study group today. So inheritance basically allows us to use things that whether you wrote it or maybe someone else wrote it and inherit those properties, so we don't have to keep writing the stuff over and over again. It's kind of like saying calling a function within a function, if you know what I'm talking about. It's kind of like using a class within a class. So what we can do here, and this is a whole lot of stuff going through, we basically know that this whole thing that we just, excuse me, this whole thing that we created here is the same code as above. The only difference here is this object class right here. So I basically create a robot called, a class called robot. And I have all that stuff that I defined earlier, right? Because remember, like, look how much stuff we wrote, right? Imagine if I wanted to make a special class instead of just robot. I wanted to make a special kind of robot. You know, like you can think of a car. If I had like a blueprint for a car, I can make something like a Hyundai, you know, and say, okay, a specific thing about Hyundai. And a Hyundai will have really similar elements to a car. It'll have wheels, it'll have a steering wheel, it'll have, you know, blinkers, lights, seat belts, all that stuff. But I can now customize saying, well, a Hyundai is this very specific kind of class of objects. So in this case, I'm going to make a garbage bot. So normally, if I wanted to do a garbage bot with all of this functionality here, think how big this class is going to be. Like if I rewrote garbage bot and I had all of this stuff plus whatever I wanted, some extra functionality, I'd have to copy that whole thing, write that whole thing. It takes a lot of work. But by inheritance, what I can do is say, hey, garbage bot, just inherit the stuff from robot. So remember, I just defined that robot class, and basically garbage bot says, all right, all that stuff that you define with robot, I'll go ahead and inherit that. Basically, like I'll learn that stuff already. So now I don't have to write all that stuff. So I can actually write a few extra properties. So in this case, I basically make my own init function. So I'm essentially in this case, I'm overwriting what the init function was in robot. And I say, okay, I'm going to give it a first name, a last name, and also I'm going to give it a battery. Okay. So before, remember, with our robot, we just had self, first name, last name. We didn't have any battery. In this case, I added some new functionality to here. And so what I can do is say, all right, I want to use the initial function, the init function from robot. So I can say, all right, super, which just means like above. So use the robot's init function, okay, called first name, last name. And then also, since we have this battery part, assign this to the object, this underscore battery, this private variable battery, okay? And so what this is really doing right here, when I say super dot underscore init, right? First name, last name, what this is literally doing, it's as if I just went ahead and said, all right, let me go ahead and copy and paste everything that's right here. Let me just paste it directly into here. That's essentially what it's doing. So it's saying, hey, go ahead and look at the super, basically, robot, use its init function to basically define first name and last name. That way I don't have to rewrite the code over and over again. Okay. Does that make sense so far, what I showed? Okay, cool. So, and then I just added a new property, self.battery, okay? And then I just added some functionality. For example, I can recharge the battery. I can make it speak, and when it speaks, it tells me about if it's happy or sad, if the battery is low or whatever. Again, just more Python stuff. I won't go into details of this part, but you can kind of get the idea, hopefully, okay? And then I basically created, in this case, a property charge, okay? So it can actually charge now, say, okay, if the self battery is less than 0, it can tell me basically, oh, is it dead? Is it low, good, high, full, etc. Okay, so I run this now. Okay, so now I have a new garbage bot. And now I can actually define a new function, just for fun, speak until dead. So this way I don't have to keep writing it over and over again. But basically I'll pass in a robot, right? So note that I didn't say what kind of robot, I just said, oh, the variable bot, okay? And it says bot.charge, since I know there's a charge property here. When it's not dead, just print out its charge, bot.charge, and then bot.speak. So basically I'll run this over and over for any robot I give it. So this is the function I wrote. So I'm kind of showing like how you can use object-oriented programming so you don't have to be very specific. You can be more generic, you can be more abstract. So now I can create my robot, Wally equals garbage bot, Wally, okay? And this will actually create my robot now, but not just any robot, it's now my garbage bot, which has all the properties of a robot plus some extra functionality. In this case, recharge, speak, and charge, okay? So now if I do this, speak until dead, I can actually go ahead and run this, and you can see it'll just keep repeating this over and over until it's dead. So you can see every time I basically ask it to speak, it loses a little bit of battery, okay, until basically it's low until the battery's dead, okay? And then you can see I can do a recharge, and then he's full. All right. Does that make sense? Again, main focus is not really focusing on like what this code is. You can probably tear this apart and kind of understand it from the Python side. The main point is to understand that I just got all the properties of robot by just calling robot here. I'm using the super to do this guy. Okay. And again, I didn't have to redefine all those setters and getters. Question?
So to be able to do that, you do have to have that word object when you first create the class, right?
That's right. So you can see that's the biggest change I made here, is that this has to already have object. And the reason why is basically, this is something that's built into Python. Python has something called object. And essentially what we're doing, we're actually inheriting for robot, we're inheriting the object from there. So robot's actually inheriting object. So we allow inheritance. Basically it's inheriting things like super. But in order to pass along its traits, you have to have this first. Okay, good question. Good point out, by the way. All right, any other questions about this? Okay, cool. All right, and I'll just show you one last one. Same idea. In this case, I make a bending bot, okay? So essentially getting the properties of a robot. You can see here, I have a bending ability now. So it's a little bit different from our previous, what do we call it? What was this called? Garbage bot. Okay, so now I have a bending bot. So it has the properties of a robot plus some extra things, for example, bending ability. It can tell me about its ability, and then I can have it bend or bend it. Okay, so I can make my bending bot now with Bender Rodriguez. Bending ability equals great, and then I can do a bend it, and you can see I have new functionality. That if I try doing the same thing, if I go ahead and try to do the same thing with Wally, you can see that this won't work, right? Because it doesn't have that ability, because garbage bot has an attribute called bend it, okay? And of course, vice versa for the bending robot. All right, so cool. So that ends the stuff I had to show you guys. Do you guys have any questions? Anything that you guys want to point out before I go ahead and end it? Cool. Excuse me. Thumbs up, thumbs down, sideways on your understanding. Okay, see some sideways, that's okay. Okay. Again, this stuff is not the easiest thing to do, and my big suggestion to you is definitely practice it. Now, as you kind of try it out, see, excuse me, see what things work out well and things that don't work. And then when you think you understand it, especially those people who are giving me the thumbs up right now, try it out and then see if you can make it break in the expected way. So like try to do something wrong. And the reason why I say that is, one, it helps you check your understanding. Say, hey, do I actually know how this works? And two, it also helps you when you get some weird error and you're like, what is this error? I don't understand what's going on here. It'll help you know in the future if when you do come across it, because you maybe did a typo or something like that, or forgot, an at property or property equals or whatever, you can kind of debug it that way. So again, the more you see it, the more familiar you are, just because the nature that you've seen it more and more often.